In Module 2, we're going to take a look at statistics and ways we gather and then look at data. So the first thing we are going to talk about are descriptive statistics. And descriptive statistics have to deal with when you're looking at lots of data. So when we are doing or looking at descriptive data, we're looking at ways we summarize and describe data numerically, and graphically. Now in this section, we are only going to talk about some numerical ways we describe and summarize data, but we will talk about some of the graphical ways we do it in later sections. And the reason we do this is we want to identify important tendencies of our data. So a couple of the things that we'll discuss later on is kind of like the shape of the distribution, where the center of our data is, how spread out our data is, stuff like that. And the goal is to then share information about the data. And when we share the information, what we're doing is identifying any patterns that the data follow. So what we're going to talk about in section 1 are two kind of ideas. The first one are measures of central tendency. So what we're talking about is where is the middle, because we're talking about center, we're talking about where the middle of the data is. And there are 3 different measures of central tendency. 2 of these are going to be ones that we're going to focus on a lot throughout this entire module. One of them we're going to discuss in section 1, but we're not really going to talk about it because it's not really useful. So the first one is mean, which is something that you have seen before. Mean is the average of a data set. So in order to calculate your mean, you add all of the values together and divide by the total number of values in your data set. Median is the middle of the data set, and the way you calculate median is by putting your values in order from smallest to largest, and then you cross off values at the ends. The last one is mode, which is the value or values that appear the most in the data set. So you're going to look for a value or values that appear more than once. So a data set can have multiple modes. The other thing is a data set doesn't necessarily have to have a mode, because if every value appears exactly once, there is no mode. So mode is going to be the one that we're really not going to look at much past section 1. It's not a great identifier of the center of our data set because there can be multiple or none, and also the location of the mode isn't necessarily going to be towards the center of our data. It could be at the lower end, it could be at the higher end, it could be towards the center. So the 2 that we're going to focus on are mean and median. Next thing we're going to talk about are measures of variability. So kind of talking about, it helps us with the shape of our distribution, which we'll talk about later, and kind of is our data more spread out, less spread out, is it close together, that sort of thing. There are 3 measures of variability. We're only going to talk about 2 of them in this section. We'll talk about the 3rd one later. So the first one is range, which is going to be a number. It is the difference between the smallest and largest values of our data set. So before, you might think of range as going from like 2 to 12, or it's not a single number, but in statistics, range is a single number. The one new thing that you may not have seen before is standard deviation. And standard deviation measures the spread in the data. More specifically, it is the average distance each value is from the mean. So standard deviation and mean are going to go hand in hand with each other for future sections. So the formula for standard deviation, we aren't going to be calculating this by hand, mainly because it is very time consuming, especially if we're going to be looking at some larger data sets, but I am going to go over where the formula comes from. So when we're calculating standard deviation, we use the symbol S. It is the sum of the squared difference between each individual data set and the mean all over n minus 1. And I did forget that all of this is also underneath the square root. One new piece of information here from this formula is the symbol for mean x bar. That is something that we're going to be using in this section and future sections. So standard deviation, it's a very scary looking formula, which is part of the reason why we're not going to do it by hand. I am going to show you about how to calculate standard deviation using the calculator though. Couple other pieces of vocabulary that we might see in this section and future sections. The first one is outliers, and outliers are values that fall outside the overall pattern of the data. Outliers are going to be something we're going to look at more so when we look at graphs of distributions. It's easier to determine whether or not an outlier might exist from a graph. And then variance is the average squared distance from each value is from the mean. Not something we're going to look at a whole lot, mainly because variance isn't super useful to us because we don't really care about the average squared distance. What we care about is the standard deviation, which is the average distance. So variance you can think of is the standard deviation squared. So let's go ahead and look at an example. So we have test scores of 26 biology students. The tests were out of 150 points and they're listed below. We're going to calculate our mean, median, mode, and standard deviation, and then we'll discuss whether an outlier may exist. So I'm going to start with mean, which we're going to do x bar. So when I'm calculating the mean, I'm going to add all of those numbers together, and I'm going to get 2,766. Then I'm going to divide by the number of data that I have, which is 26. And I don't get exactly 106.38, but I only ever require you to round 2 decimal places. So to 2 decimal places, my mean is 106.38. I'm going to do mode next. So when I'm looking at my data set, there are 5 numbers that appear twice, and that's the most any number appears. So we're going to have 5 modes. So the first one is 88. Then we have 104, 108, 112, and 139. So I'm looking at the mode compared to the mean. 108 is a mode that is fairly close to our mean, so that might be a good measure of the center. But my other values, 88 is really small, 139 is very big, 104 and 112 are kind of like in the middle. So mode is not a great identifier of our center. Now we want to calculate our median, which I'm going to abbreviate MED. So I went ahead and I have listed my data in numerical order. So now I'm going to start crossing off my data starting at the ends. And I'm going to keep crossing off my data until I'm left with one number remaining. So it actually happens in this case that I end up with 2 numbers. And the reason this happened is because there are an even set of numbers in our data set. If there were an odd set of numbers, I would have ended up with 1 number left in the middle. So because there are 2 and they happen to be the same, I know my median is 108. If these numbers had not been the same, I would have then needed to add those 2 numbers together and divide by 2 in order to get the median. So before I talk about how to calculate standard deviation, I am going to discuss outliers. So the 2 things that we look at in order to determine if there are outliers are the mean and the median. So if our mean and the median are close to one another, there is less likely to be an outlier. So 106.38 and 108 are fairly close to one another. So I would say there is not likely to be an outlier in this data set. If my mean were something like 92 and my median was 108, then I would say that there's a good chance an outlier exists in our data set. But based on our current mean and median, not likely that an outlier exists. So the last thing we're going to talk about is standard deviation, and we're going to discuss how to do that in the calculator. So in the calculator, standard deviation is abbreviated SX, and that's because there are two standard deviations. There's a sample standard deviation and a population standard deviation. And we're going to be dealing with sample standard deviation. So I'm going to discuss the steps on the calculators that we have. If you have a graphing calculator, please let me know and I'll go over how those steps are slightly different for that calculator. So the first step is to hit the data button on the calculator and enter your values into your list one. So you just start typing the numbers and hitting enter between each one. The next step is to hit second and then data. And then what you want to do is select the one var stats. And then you want to go ahead and hit calculate. No matter which calculator you use, that third step is the same no matter the calculator. You're looking for that one var stats. And you may have to scroll depending on where it appears. The order of these things aren't the same on every calculator, but if you look for the one that says SX and we get 21.12. So that tells me that on average, each value is a distance of 21.12 from the mean. So this tells me that I have a fairly large spread in my data. 21.12 is a very large standard deviation. If my standard deviation had been 2.112 or 2.12, then I would say that there was a small spread in my data. So the data is more close to the mean and close to each other. So larger standard deviations indicate larger spread in the data. Smaller standard deviations indicate a smaller spread in the data. The other nice thing about the one variable stats on the calculator is it also tells us our mean and our median. The very first thing that would have popped up on your screen is the X bar. So you can double check that you've done the mean by hand correctly. You can also scroll down farther and see median, which is very useful when we have lots of data, and especially if our data isn't already in numerical order. This cuts down on the time of putting it in order first in order to calculate your median. Please let me know if you have any questions about any of the terms we've discussed in section 1, how to calculate anything, or how to use the calculator to find any of these values.